So, good morning, everyone. In the last classes, we discussed what this particular data was. Today, we can look on the topic types of data distribution. That is, types of data distribution. So, first of all, coming to what this particular distribution is. As per Statistics in Plain English, 3rd edition 2010, a distribution is simply a collection of data or scores on a variable. That is, a distribution is simply a collection of data or scores on a variable. Now, usually these scores are arranged in order from smallest to largest and then they can be presented graphically. So, this can be called as a distribution. Now, introduction part. The distribution of statistical data or population is a listing of functions showing all the possible values or intervals of the data and how often they occur. That is, the data and the frequency of the data. Together we can call it as distribution. Now, when a distribution is categorical, we know what the different types of data. It can be categorical data and numerical data. So, when a distribution is categorical data is organized, you see the number of percentage of individuals in each group, that is dead or alive after treatment. We can say that 60% of the population were dead while 40% were alive. That's the way we will organize particular data obtained from a category. Now, when a distribution of numerical data is organized, that is, for example, blood pressure, HP levels, they are often ordered from smallest to highest, broken into reasonably sized groups. Now, if appropriate, and then put into graphs and charts to examine the shape, center, amount of variability in data. So these are the two ways in which the data can be organized. That is, data can be of two types, categorical data and numerical data. In case of categorical data, what we will do is that we will put the number in each group and we will put the percentage. And in case of numerical data, it can be ordered in from smallest to highest or highest to smallest. Again, we can order them in a group. We can draw a graph on them also. Now, the second part which comes under this particular distribution is density functions. Density means how much a particular data is there for a particular group, or in other words, in simple terms, the frequency. The distributions are often described in terms of the density or density functions. The density functions are functions that describes how the proportion of data or likelihood of proportion of observations change over the range of distribution. For example, we can say that from age group 5 to 10, 20, 20% are there. From age group 10 to 15, 14% are there. From age group 15 to 20, there are around 25%. That is how the likelihood of changing the particular data, proportion of data, can be termed as density. Now, two types of density functions are probability density function and cumulative density function. That is, density function can be of two types, probability density function and cumulative density function. The probability density function calculates the probability of observing a given value for a given function. For example, between age group 25 and 30, what is the probability of observing? That is, how many number of persons will be there. This can be termed as probability density function. Now, cumulative density function calculates the probability of observation equal or less than a value. That is, after the age group 30, how many will be there? This can be termed as cumulative density function. Or before the age group of 25, how many people are there included in the study? This can be termed as cumulative. That is, two types of density functions, probability density function and cumulative density function. Probability density function means observation of a given value in a given time. It can be termed as probability density function. Cumulative density function means before or after a particular point, how many values are there. Now, coming to the types of distribution. There are different types of distribution, data distribution, and the most common type is normal distribution. Generally, it can be divided into normal distribution and non-normal distribution. So first we can discuss about this particular normal distribution. Now, this particular normal distribution is also termed as Gaussian distribution. Actually, this is the original name of normal distribution. What happened is that this particular name is given after a noted statistician, Professor Carl Friedrich Gauss, who not invented, he first observed this kind of distribution. So he described this particular distribution and termed it as Gaussian distribution. Later on, this particular Gaussian distribution was named as normal distribution. Now what happened is that data from many fields of study surprisingly can be described using a Gaussian distribution, so much so that the distribution is often called as normal distribution because it is so common. What happened is that whenever scientists put some kind of data, for every data it commonly occurred in Gaussian distribution. So now they started calling it as this is the most normal distribution or most common distribution, so we can call it as normal distribution. That's how this particular name normal distribution came. Originally it can be called as Gaussian distribution. Now it is an example of continuous probability density function. That is in the last slide we studied. Probability density function, that is for a given value what is the density. So normal distribution is an example of probability density function. Now usually what happens is that the data from most of the medical experiments, it will usually follow this particular normal distribution pattern. Now the normal curve describes the ideal distribution of continuous values, that is heart rate, blood sugar value and HP level. The data when plotted in a graph is symmetrically distributed on both sides of the mean and form a bell-shaped curve in frequency distribution plot. That is, it will usually follow a bell. We know the particular structure of a bell. When the data is plotted, what happens is that the particular data will follow a bell. That is, we can obtain a bell in the particular graph. Now, a Gaussian distribution can be described using two parameters. That is, how we can describe the data which can be obtained in Gaussian distribution. It is usually described using two parameters. First of all, mean. Mean means it is denoted by a Greek lowercase letter mu and is expected value of distribution, that is the average. Now variance, denoted by Greek lowercase letter sigma raised to the second power, that is sigma square, based on the units of variable r squared, and described the spread of observation from the mean, that is how much the original data is varying from the mean. Now it is common to use a normalized calculation for variance called as standard deviation. Now standard deviation is denoted by the Greek lowercase letter sigma and describes the normalized spread of observation from the mean. Now the equation for normal distribution is, you will have to just look into this particular equation. The normal probability density is y is equal to 1 by sigma root of 2 pi into e the raised to minus 1 by 2 whole x minus mu divided by sigma the whole square, where sigma is the standard deviation, mu is the mean, x is the value of observation and y is the ordinate of normal curve in a function of x. Now this is the bell-shaped graph which we will obtain when we are plotting values of a normal distribution. So this is usually following a bell shape, and what I said earlier was the particular midpoint will be the mean or the 0 point will be the mean. Now the most important concept associated with normal distribution is the empirical rule. That is, first of all, before going to that, we can come to this particular mean. Mean means the average. That is, if there are 100 number of observations, if I am for example, if I am calculating the age, mean of the age in your class, there are 30 observations. So what I can do is that I can sum up all your ages, 30, 26 plus 21 plus 22 plus 23 plus 20 plus 19 plus 20 plus, likewise 30 numbers I will sum up, then I will divide it by 30. So the value which I will obtain will be the middle point or will be the mean. So this will come in the middle point and both the data will be evenly spread after the mean and before the mean. That is mean. Now what is standard deviation? Standard deviation means, for example, I am getting the mean of your class as 21.2. Now how much your age is different from the mean? That particular value is termed as standard deviation. For example, I will get the standard deviation as plus or minus 1.6 years. That is, if I am saying your mean is 21.2 years, then your age group, your age may be, or the age of a particular person in the class may be 22.8 or 20.6. Likewise, the difference can be termed as sigma. Now, an empirical concept associated with normal distribution is the empirical rule, that is 68.3 population is contained within one standard deviation from the mean. That is, if I am plotting the particular values of age group of your class, I can see that almost 68% of the people will be having their ages between one standard deviation, that is plus one standard deviation or minus one standard deviation. Now 95.4% of the population is contained within two standard deviation. So if I am taking a length from this to this, I can see that almost the age of 95.4% persons will come between these 2 points. Now 99.7% of the population is contained within 3 standard deviations from the mean. So between these two values, there will be the value of 99.7% of the age group. So this is the concept of normal distribution, or empirical concept of normal distribution. Now, in ideal distribution, the values mean, mode and median are equal with population understudy. That is, in case of normal distribution, what happens is that the midpoint will be same for both mean, median and mode. And we can come to this concept later on. Now, what happens is that the normal distribution skew is 0. That is, if you look into the previous slide, the particular midpoint, that is mean, median, mode, the normal distribution is 0. That is, we are getting an identical shape on both sides of the mean. Now, if the difference mean, median is positive, the curve is positively skewed. If you are getting a difference in a positive side, that is, a bell is more here, bell is less here, this kind of graph can be called as a positive skewed normal distribution. Now, if the mean, median negative, the curve is negatively skewed, and therefore the measure of central tendency differs. For example, if we look, the bell is more here. When we draw the bell, we get more amount of data here and less amount of data here. We can say that this is negatively skewed. So there is normal distribution, there is negative skew, and there is positive skew. Now next one is non-normal distributions or non-Gaussian distributions. Now if the data is skewed on one side, then the distribution is non-normal. It may be binomial distribution or it may be Poisson distribution. That is, if either of these particular graphs occur while we are drawing if either of these two graphs occur, if when we are drawing a particular or plotting a data obtained from a particular experiment, then we can say that the distribution is non-normal. So this can be either binomial distribution or this can be Poisson distribution. First of all, coming to binomial distribution. So we had earlier seen what this particular binomial data is. What was binomial data? A data which consists only of two parameters, yes, no, dead, alive, treated, non treated. This kind of data can usually be called as binomial data. So what is binomial distribution? The binomial distribution is a probability distribution that summarizes the likelihood that a value will take one of two independent values under a given set of parameters or assumptions. That is, it can take only one of the two assumptions, yes, no, dead, alive, treated, not treated. Now, in binomial distribution, even can have only one of the two possible outcomes, such as yes or no, positive, negative, survival of death, smokers, non-smokers. The binomial distribution is a common discrete distribution used in statistics as opposed to continuous distribution such as normal distribution. That is, what I said here is that binomial distribution is a discrete distribution, while this particular normal distribution was a continuous distribution. I hope you remember the terms what discrete and continuous are. Now, the binomial distribution is completely defined by two parameters. First one is that the probability of one or the other outcome, and the next one is number of trials or observation. That is, two parameters are there in binomial distribution. One is the number of observations, that is number of trial observations. Usually it is 2, yes or no. And the second one is the probability of one or the other outcome. In yes, how many people? In no, how many people? That is, given these two parameters, we can calculate the probability of any specified number of successes in n trials. The probability of success or failure lies between 0 and 1. That is, it can be either yes or it can be no. No means 0, yes means 1. The probability of the outcome of a binomial experiment consists of n trials can be computed from the expansion of the expression, that is p plus q the whole raised to n. Now, where p is defined as the probability of success and q is defined as the probability of failure, and n is the number of trial observations. Next one is Poisson distribution. Now, this is named after a French mathematician Simon Denis Poisson. It gives us the probability of a given number of events happening in fixed interval of time. That is, what this particular Poisson distribution is, that how many number of events are happening at a fixed interval of time. For example, every day we are hearing the news. At 6 o'clock there will be the number of corona cases in Kerala. So that is, in the past 24 hours, how many number of corona patients newly identified. This is usually termed as Poisson distribution. So if you take a weekly plot, that is in Monday 6,000 patients, Tuesday 4,000, Wednesday 7,000. Likewise, if we put a distribution, it can be termed as Poisson distribution. The Poisson distribution is a discrete function, meaning that the event can only be measured as occurring or not as occurring, meaning the variable can only be measured in whole numbers. Now, the main significant thing is Poisson distribution is that Poisson distribution is also a discrete data. Now, coming to the short points, a Poisson distribution is a measure of how many times an event is likely to occur within X period of time. For example, how many cigarettes do you smoke in 24 hours? Another example, a video store averages 400 customers every Friday night. What is the probability that 600 customers will come in on any given Friday night? This can also be a probability distribution or a Poisson distribution. Now, in quality control, the probability of observing a defective item is often calculated using Poisson distribution. The probability of observing X events of a given kind in n observations, where the probability of observing the event is single observation is p, that is p x is equal to lambda xe minus lambda divided by x star, where lambda is np, that is n is the number of observations and p is the probability of observing a single observation, and n is equal to number of observations. So this is an equation for Poisson distribution. Now next one is t distribution. We can just study two more distribution, and the first one is t distribution, because one of the major tests which we will be doing in our statistics is a t-test. Now it is a distribution that arises when attempting to estimate the mean of normal distribution with different sized samples. That is the most common experiments which we do in this particular medical statistics. Now this distribution can be constructed by repeatedly taking samples of size n from a normal distribution and computing the statistics. T is equal to x bar minus mu divided by s divided by root n, where x is the sample mean, mu is the true mean of the normal distribution, s is the standard sample standard deviation, and n is the number of observations. The exact shape of t distribution depends on the sample size, that is degree of freedoms, and but the t distribution is symmetrically distributed about a mean of 0. Next one is chi-square distribution. The chi-square distribution is denoted as a lowercase Greek letter chi, that is x, raised to the second power x square. The chi-square distribution has one parameter, that is degree of freedom, denoted by k. An observation in a chi-square distribution is calculated as sum of k-squared observations drawn from the Gaussian distribution. So what we are doing is that from a normal distribution, that is normal curve, how many k-squared observations are obtained, that we will isolate, and from this we can calculate the particular chi-square distribution. The chi-square distribution may be derived from normally distributed variables defined as a sum of squares of independent normal variables, each of which has a mean 0 and a standard deviation 1. Thus, if z is equal to normal with mu is equal to 0 and sigma is 1, that is chi-square is equal to z square, that is mean z I square. The chi-square distribution is often used to assess probabilities when comparing discrete values from comparative groups, where the normal distribution can be used to approximate the discrete probabilities. So thank you very much. Kindly feel free to revert back in case of any queries or concerns.